So I think we are in a good shape to start right now. There is no more coming. So before we start, I would like to highlight something very important for such a presentation. This presentation, it means to speak about the Turbomachinery online system and configuration introduction. Here, what we are really looking for is to give you an introduction about the hardware and how to and where to start. We cannot, cover everything in the same sessions because this is a very complex topic. So what we would like to actually present here to simplify things. We have a different expertise I can see because some of the people I can see from the list, I know them well. They are quite experienced, and there is some people, maybe this is a new topic for them. So we would like to mitigate as much as we can. Okay, safety first. And when we meant here safety first, please, Turbomachinery online system is very sensitive system. And it's controlling a very quite critical assets in your plant. So please don't do any kind of modification or don't try to modify things without any complete supervision from a concerned persons or expert, either from your plant or from the OEM or from the vendor themselves, because we don't want things to happen in a direction we would like to see a consequences of shutdown or trip your plant. So please make sure to have this one with the escort to the supervisor, or let's admit another person. Okay, right. Right. What is the agenda? Let me admit some people actually. I'm trying to slow down as much as I can, and we will run very quick later. What is the agenda we're going to discuss today? In very quick, we're going to discuss what is the turbomachinery and arrangement overview. Let me admit more, and we will speak about introduction for the typical sensing element utilized in the turbomachinery, and we will give like a very quick overview. We're going to introduce the vibration proximity probe, accelerometers, and velocity sensors. We're going to make some kind of simple definition of vibration online monitoring system and how to make things simple, because most of those people, they are working in such a field of experience. It seems to be for them the online monitoring systems is a black box. What we are here looking for is to make it clear and simplified it to understand, to be understandable for all. We're going to discuss the differentiation between the different types of vibration online monitoring systems. We're going to speak about the common international standard used for such systems like this. We're going to discuss the introduction to the vibration online monitoring system architecture, where you can see or to start to build your online monitoring system. How and where we start to build your vibration monitoring system, introduction to the signal types, vibration online monitoring system, main products. I think this one, what we meant by main product, when you do your configuration, you got the raw data and what kind of products, like the spectrum, like the overall trending, shaft center line, orbits, full spectrums, all these kind of stuff, they are a product. Even the output from the rack or your online monitoring system, this we can consider it as a product from your system. Then we're going to discuss the main vibration online monitoring system hardware components in a very quick overview. Then how to prepare something, we call it a bill of quantity, or based on something we call it a IO list, how to build your final bill of quantity when you design or the configure online monitoring system. Okay. Turbomachinery arrangement. First, we need to ask ourselves a question. Let me admit some people, they are coming here. I don't want them to miss a good information. because we're gonna start from this slide. Okay, so what is the turbomachinery and what is meant by turbomachinery? It's a very common name for a machine which is driven by a turbine. This is from where the word of turbo came over. So if you can see here, this is a typical arrangement of a turbomachinery. If you can check here, there is a there is a gas turbine here is driving a gearbox, and this gearbox is driving a compressor, multi-stage compressor or multi-stage pump. So this is one of the typical famous arrangement of the turbomachinery. So a very confusion question here, are all the turbomachineries have the same structure? In a common way, yes, most of them, they have the same structure with respecting the OEM design, because we can call GT is a gas turbine. It's a gas turbine driving an application. Can we call the turbomachinery a steam turbine? Yes, we can call it a turbomachinery. Turbo expander, which is a compressor driven by a turbine in a combined cycle, and it's very compact size. This is, we can call it a turbomachinery. Yes, we can call it a turbomachinery. But most probably people, they are looking for a driver, okay? Or the main purpose of this asset is to drive another application. So the other application here, it's a part of this turbomachinery. So it's not all the time the machine equipped with the vibration online monitoring systems, the turbomachinery. So what is the case if I remove this driver to be electrical motor, high tension for instance, or medium tension? Okay, still we are not call it a turbomachinery, but still the vibration online monitoring system will be applicable for such a application like this. So pumps, electrical motor, gearboxes, fans can be equipped with the vibration monitoring, online monitoring system as well. It depends about the manufacturer and what's happened on the feed stages. When I mean feed, is the front end engineering design phase, where the OEM communicated with the designer and they select such a suitable equipment for a suitable stream. I will assume that most of the people, they understand the language of the oil and gas, but I will try to manage it as much as we can, because we have something, we call it in oil and gas mainstream or auxiliary stream. So if your critical machine is serving mainstream, we call it a mainstream asset. Okay, so we need to agree about something. So not all turbo vibration condition monitoring is not only designed for the turbomachinery. It might be mixed up with another machinery. Sorry, gents, if I'm slowing down from time to time, because I'm still, I assume that we have admit all, but I'm still receiving requests for joining. Okay, so let's now introduce the sensing elements. I used to call the sensor, it's a sensing element, rather than call it vibration sensor or temperature sensor or so and so. Why? Because actually at the end, you design a small assets serving another purpose, which is sensing something you would like to target or to know what is the output of this monitoring parts. So if we are speaking about vibration itself alone, we have something, we call it a displacement vibration sensing elements. And we have two major outputs of the displacement vibration sensing element, static and dynamic. This is very common, known as a commercial name, eddy current probe or proximity probe. We have the vibration the velocity vibration sensing element, and this is commonly used to measure the absolute vibration on the casing, especially for the GTs and STs. STs, we call it steam turbines, and GTs, we call it a gas turbine. And later on, you can put another letter to know what is the driven machine or the application you would like to attach. So if we say the GTG, so this is a gas turbine generator train. Okay, so The third type of the vibration sensing elements is the accelerometer, which is the most common one on the industry. And by the way, statistically, we can say the total market share of the accelerometer globally is more than 80% of the vibration sensor is accelerometer. But displacement probe or the proximity probe, it's very famous because it's controlling a very critical assets or very critical rotating equipment machinery. That's why it's very famous, and it seems to be for you, it's a very big and popular. But the accelerometer, actually, it's more in the market share if we are speaking in the statistics. Okay, axial position, and this is a static sensor. This is actually a displacement probe or proximity probe to sense only the axial positioning of the shaft itself when it's try to fluctuate on the axial direction. Rod drop sensing elements. So just to admit some more. Okay. Rod drop sensing elements, as you can see here, we're speaking about rod drop. The rod drop, most probably, it's for receive machines. Receive, it's a reciprocating machines, like a reciprocating compressors. So when you need to measure the total sag of the drop of the rod. So here you can utilize the same idea of the displacement probe. So please don't be panic from different type of the sensor. At the end, here is a proximity probe. So when you buy it or you design it or you select it, it will end up with a displacement vibration sensor. So later on the next slide, we need to know how to select it or what is the most common, let me admit some extra people. Okay, how to select your displacement probe and what is the different on item where you choose your selecting elements. Differential expansion or LVDT, this is the linear variable differential transform. This is actually differential expansions. This is, by the way, it's very common on the oil and gas, where you have steam turbines or gas turbines. I would like to know how much is the maximum expansion my total casing will reach to. And some of the manufacturer, I don't want to mention names, they are make it as a mandatory when they manufacture the steam turbine, where the expansion is a common player of the monitoring, the online monitoring system. Valve position, this is commonly used to know the valve position, especially used when you are controlling the STs. So it's a very valuable information, and it's the same idea of the displacement vibration, but this is a static reading, or you get a static product from it, not a dynamic. Of course, we don't have a time to describe what is the difference between static and dynamic, but to give a quick hint, static is a quantitative number. When you build your decision or a number, numeric number, like if I tell you which one is greater, 1 or 3, so definitely we say 3 is greater than 1. So if I tell you what is 2, in order, your brain will distinguish that 2 is between 1 and 3. So electronics, it can be, configured or programmed. Let me accept some people here. Okay, so the dynamic here, when you measure the dynamic signal, okay, coming from the sensor itself, and you need to record some relation between the variation of the amplitudes and the time domain. So you will get at the end a raw data, which is a time of 4. Once you get this raw data, you can drive any kind of products later on from these dynamic. And by the way, this word is not a simple word, static and dynamic, because this is the biggest dilemma between the vibration specialist and the E&I, the instrument and electrical and instrument engineers on the, let me admit some people, okay, on the oil and gas, because this is a scope of whom and who has to select. So this is a create a big dilemma, and why most of the E&I engineers, they are leaving this kind of job in the shoulder of vibration specialists. Okay, speed and phase mark sensing elements. So this is when you target it from the name itself, when you target the speed or the phase mark. And by the way, this is end up with the displacement vibration sensing elements. This is a proximity probe. There is a different type of the measurement. Speed, you can lean on the tachometer or optical way. And by the way, there is some way to connect it with the online monitoring systems, but we don't have enough time to discuss such sensing elements in our presentation. Okay, over speed, it's very important, and this is how to control, especially for the STs, how to control or to manage monitoring the speed of your assets. Okay, a 1 million question here I like, are all monitoring and control sensing elements vibration? So the answer of this one is, it's a big no, because now we are leaning on something. I will discuss it in the next few slides. Most of the people, they are thinking that the vibration sensor, it's just only made for the online monitoring system. Even some people, they call it VMS, vibration monitoring system. Sorry, but this is not 100% true, because we have another game changer players here. These kind of sensing element or sensing monitoring elements, it will be utilized or used for controlling the turbomachinery control philosophy. When I say a turbomachinery controlling a philosophy, it means that you can interfere your control. So I will discuss this one in a minute. These sensors commonly called the indirect measurement, and we will tell you that the indirect measurements, how we can control it, and what does it mean indirect measurements. The first one is the temperature sensors. Temperature sensors, and we can say a lot of people, they witness and the experience your turbomachinery has been tripped due to what? Due to a temperature sensor alarm. So the relay, where we discuss the relay later on, it will trip your machine. So if I am saying tripping the machine, it means that you are interfering the control. Who's having the upper hand here? Is it the automated system or the operator? So the automated system here, it can say or stand the same word where the operating can say. So it can decide either to keep the machine in the operation, or it can stop it. So it's a very important and critical. That's why we will discuss later on, the temperature is one of the game changer on the vibration monitoring system. What type of the vibration temperature sensing elements that we have? It's very common. We have a big four actually. Most common for all of you guys is the RTD, the resistance temperature detectors, and the thermocouples, thermosets, and you have the semiconductor. And by the way, this is a common used at the moment for the accelerometer and for the vibration accelerometers. You can see that some of the accelerometer now is combined with temperature semiconductor to the acceleration output. Okay. So this is a very important note. I would like all of you to understand it very well, because this is common on the misconfusion or misunderstanding. What kind of temperature sensor I'm using on my monitoring? There is something we call it a stream temperature monitoring and protection sensors, where you need to put a transmitter on the stream itself to control the stream. For instance, if you have a GT and you would like to know what is the temperature of the exhaust, okay, is this one a machine temperature monitoring, or this one is a stream? So once it's getting in touch with the media, like if you have a gas compressor, and the gas compressor, you would like to know the performance of it, and you would like to control the temperature, so you need to put a sensor temperature transmitter in some way or somewhere on the pipe itself, or discharge, or suction, whatever is according to the designer, to know exactly what is the stream monitoring. This one, by somehow, it's indirect connecting to your vibration monitoring systems, where it can control the machine, because it's connecting at the DCS, where at the end, the DCS is the major brain of your system. So machine temperature monitoring, where it's very famous, you can find it where, sorry, Jens, like the tilting bad RTDs. This is what we call it, a machine temperature monitoring, where you can put the semiconductor on the pedestal of the bearing, so you can control the temperature of the bearing itself, so you can connect it direct to the VMS. By the way, connecting the temperature sensor to the VMS, it will end up with the static values. So what you are looking for is something we call it an instrumentation 4 to 20 milliampere output. So you can take this linear values, and you can put it on a scale. You can take it direct to the VMS if you would like to be a fully comply with the API 670. It's coming in the next slide. But you can use another PLC or external PLC to speak to the DCS, and the DCS will decide later on according to the logic if it will interfere the control or not, or what kind of command this sensor it needs to take an action beyond. Let me add another persons. Okay. So there is a few of sensing element. It's a game changer as well. The flow control and regulate sensors. When you can monitor the flow itself, and this is mainly, it will be on the mainstream. And by the way, don't consider the Turbomachinery is a solid machine like a standalone system. It's not a standalone system. It has a downstream and it has a upstream lines, and this is can dictate your operation. Pressure control and regulate sensors. This is where you are looking for the pressure values, and it will end up with the transmitter, so you can translate it to the static value. Let me admit some people more. Okay. Load and current sensing elements. Why I'm wasting our time explaining these kind of sensors? Because this one is your open gate for the industry or industry 4 or the digitalization. Because the vibration sensor itself, as a standalone sensor, it can't take the decision alone. But sometimes this decision it will be at the last stage before the failure. But if you build some kind of algorithm to know what is Mr. Sensor, Mr. Temperature sensor saying, and what is the Mr. Flow sensor saying, and what is the pressure, load, and current sensor saying, you can make some kind of logic. So you can build the machine learning. So the machine itself, it can recognize if this anomaly happens due to a load exchange, or it's happened due to a real failure, or the failure is coming and I can see there is a kind of escalation. I can statistically compute this kind of escalation. It can help me for my decision, and I can automate this one. This is a very important point, and this is why I put this slide. Like, very quick overview about the proximity probe. Proximity probe, it's a very simple probe. I'm trying to simplify things. Okay. Later on, if you would like to, attend some of the courses, valuable courses for the vibration. I'm one of the teachers from the Mobius Institute in the Middle East. So we can discuss this one on details in our courses. But the components of the vibration proximity probe, it's very simple, and it has the three components. You have the proximity sensor or the probe tip. This is what we call it, a sensing element. Later on, you have the extension cable, and you have later on the driver or the modulator or oscillator. From this point, the sensor is ended. Why we are saying the sensor, it's a three pieces, because you cannot manipulate any of these elements. When you buy a sensor like this, you need to know what exact probe you would like to choose. And this probe, it has to work with some kind of known extension cable. We call it the system length. And according to each probe, the system length, it has to be selected with this model. And the driver or the oscillator, which can oscillate the ED current at the end, it has to come to be compatible with the extension cable and the proximity probe tip. Later on, you have a wire. This is a field wiring. It's a three conductor shield field, or you can say it's a normal wire. It's actually special wire when it comes to oil and gas or standard, but let's simplify things. It's a three-leg wire or four-leg wire. You have one is the volt input, and you have a common, and you have the output, and you have the fourth leg, which is the grounding. So this is a normal cable. You can buy it from anywhere. By the way, this can come as a multi-core. So the multi-core, it can serve more than one service. Proximity probe, what I mean. What is the important proximity probe? To know exactly what is the provision of it and what is the tip size. When I say the provision is the inactive length, where you can see the thread here, when you can control the thread or the installation length. It will be written in your technical data sheet of the sensor, and the effective coil tip. This is actually, it's a coil. Inside there is a coil, it's a copper coil, and this is actually coated with the epoxy, very special epoxy material. And some of the other manufacturers has different material. Don't want to speak on manufacturer from time to time. Different size. This size of the proximity tip is coming different sizes. So you can see it like a effective diameter like a 8 mm. So you can find like a 5 mm, you can find 11 mm. And later on, you can select your system length. It can, you know, the unit of it by meter. I don't know if you are using the, let's see the chat box. But there is too many questions here. Is it possible if we can address it at the end? I will read it one by one. Okay, so we can return back to it. The same typical arrangement of the proximity probe, you can use it in different applications. Like you can use it for the speed, you can use it for the thermal expansion, you can use it for the over speed, you can use it for the axial position, you can use it for the rod drop. It's the same probe at the end. There is actually two types of the proximity probe. There is something we call the straight mount and reverse mount. Later on, we can discuss the difference in details during the courses. But this is actually a shape of the reverse mount sensor, when we can control the provision by controlling the thread and the gap. Okay. Accelerometer transducer, it's very common in industry, and I don't want to waste a lot of time on it, but it has a different shape, different manufacturer, different sensitivity, different arrangement of the seismic mass inside, and this arrangement is to be discussed on details in any kind of course. By the way, this is one of the very new sensors. If you can see, this is the actual size. I put it in actual size. This is scale 1:1. This is 100 volt, 100 millivolt per G multi-purpose accelerometer. LVTT, because I was not intent to put this kind of slide here, but most of the people, they don't know what is the LVTT. Here, when you have a huge mass or a huge body, and it's getting heated up by stream or like a GT, like a ST, and you expect expansion. So the expansion here for you, you need to know exactly when this thermal expansion, it will end up. So you need to monitor it by putting a cooler or a stopper, and this cooler, it will be monitoring the gap between the tip of the sensor and between the LVDT. Common used international standard, most probably in the industry. Let me admit some people, they start joining now. We are about to finish. Okay. The common used international standard, let's speak about the oil and gas more, because I'm oil and gas oriented, is the API standard 670. This is the most common use standard, and the Shell DEP. So those two standards, they are describing you how to select your hardware, what kind of elements you would like to use, what is the kind of range. Okay. So API actually is the American Petroleum Institute. So it means to mint the petroleum industry. But I'm not speaking because this is the racism. If there's some people, they are joining from Siemens or the power, or by the way, you can utilize the 670, but sometime it will be over spec for you. And by the way, there is some big companies worldwide, they are not using these kind of the standard. They have their own standard, and some of the manufacturers, they have their own standard as well. But most commonly, if you are using oil and gas project, the first question you will ask if the hardware itself is totally comply with the API standard and or Shell DEP. Like, what is the vibration monitoring online system? The online machine condition monitoring system is this, in a simply say word, is the system provides the method of continuous monitoring a target assets. When I say a target assets here, I meant to mention assets, because we don't want to make a turbomachinery only, because you can find some of the online monitoring systems is designed for a pump. for instance. It's designed for a compressor, for the electrical motor. So please, again, don't take this one as a rule of thumb, or don't make a link between the vibration monitoring system. It's just only for the turbo machinery. The target assets, you need to compute something, we call it a criticality assessments need to be computed. If you would like to know whether you're going to use this kind of, I think, Rao, are you doing some kind of, okay, because I have some kind of lines popping on my screen. Okay, type. The online machine condition monitoring systems is function of time. So when we say this a function of time, this is a game changer. Why? Because it can classify the condition monitoring or the online monitoring system in a categories. So the first one, we have the continuous protection system, where it's fully comply with the API 670. It's a protection system. It leans on a static values, and you have some kind of relay. Then you need to take actions when you reach to some certain of threshold values. Like what? Please operate from 1 to 2. You are fine. But when you reach to the 5, take an action. When I say take an action, this action you can do with anything. You can take it to the lamp. You can take it to the SCADA system. You can take it to actual physical actuator. So you can actuate something and you can control something. Like if I install it on, simply say, on electrical motor, and you have put some vibration sensor and you reach some certain gap of the bearing, so the proximity probe, it will trigger you because you reach this static quantitative number. So the threshold reach here, it will go and interfere with the operation. Okay, so let's move back to this one again. Continuous protection system, non-API 670 comply. This is for those people, they are running the system beyond the petroleum companies. You have a continuous protection and monitoring system allowing the dynamic data analysis. Here, this is, we call it a VMS or monitoring system, where you can protect your machine plus save a data or products coming from the dynamic reading. So the dynamic reading, it can be translated to some kind of useful analysis data, and this is very important. And let's say this is the bread and butter of the vibration online monitoring system. But unfortunately, most of common project feed that I already shared earlier in my whole experience, the vendor or the OEM themselves, they will go direct to the continuous protection system. They will ignore the monitoring system because they're thinking this is the over cost for the project. But for us as analysts, you cannot see the event before the failure happened, because the protection system, it's just stop the failure to open the door, or it can stop the failure when it just opened the door. So here, later on, you cannot find the root cause of the problem. I think the previous lecture where Mr. Salahi presented about the RUB, you cannot do anything of the condition protection system, continuous protection system, if you don't have the dynamic data. Let me admit some people. Okay, right. There is the last one is the sequential or the multiplexer protection system. This is allowing the dynamic and the data analysis. This is non-API 670 comply, where there is a huge gap between the serving time, where you serve the data to the monitoring system from the sensing element, until you end up with the, there is something in the chat box. We have more 5 minutes max here. Okay, sorry Salah for this. I'll continue very quick. Right. Typical arrangement. This is exactly what we call it, a typical arrangement. This is exactly what you need to do when you start to build your or to configure your hardware selection. You put arrangement of your machine. This is you can get it from the OEM of the machine itself. So if you have generator, you have the LP steam turbines, high pressure steam turbines, and so and so. Later on, you give a number for each sensor to know which type of each sensor there. Based on these kind of sensors, you need to write it in something later on. We call it IO list. Okay. typical system architecture. What does it mean, a system architecture? It's just a system architecture. It's a drawing to show you the relation between the machine level until you end up with the control level. Where here most of the condition monitoring engineer, they have a dilemma of understanding the system, or they can see it. I would say it is a barrier. Okay, they don't understand where I'm standing. I just standing here or standing there or standing over there in the control. And if it comes to the control, I don't understand. This is a black box for me. It's not a black box. We'll show this one in a minute. So here, something we call it a system level. This will let you to understand the level very quick. Something we call it application or transducer level, where this is the machine in the field. So where you install your sensor and the cable until to reach to what? To the monitoring level. So the monitoring level, it might be you have two scenarios, either local monitoring system or a control-based monitoring system, the control room. So this one, it can be locally installed in the close to the machine, or you can take it direct to the control room. It depends about the distance between the assets need to be monitored. Sorry, Jens, I lost. Sorry, I lost the microphone. And this is the monitoring level. And as we said, you have two scenarios. The third level, actually, what we call it, the analysis or the diagnosing or the decision maker level. Here, when you just digitized all the signal and you just send it as an output product to the software. The software, when I mean a software for the analysis part, or a protection system where the DCS or the brain, it can control your asset. So for instance, if you have a faulty signal coming from the transducer level, it has to go direct to the monitoring system, and the monitoring system itself, it can be standalone, so it can go return back to interfere the operation itself. Chat box, I apologize in the, okay. Okay, gents. So this is the three major level where you need to understand exactly when you design your system. What is the vibration online monitoring system? Here to show you in a deep idea. This is the machine level. This is when you have the system monitoring level. And by the way, I don't have a time actually to speak about everything about the portable, like the Kengen or the ADRI system, how to convert, or the DAC boards, when you convert the protection system to a dynamic system. We don't have a time actually to discuss it all. Then later on, you go for something, we call it the vibration analysis diagnostic system level. And one thing here is very important for me, and for future, you're going to see it a lot. Where is something we call it the OPC, where you need to interfere the vibration values with another sensor that I told you about, where these sensor, it can speak together to build the logic. That's why I put it on the side of my presentation. Now, the main vibration monitoring system, or the hardware, we call it a rack system. This is very common. It's 19-inch rack with the backplane. This is the backplane, where you can find, it's like a computer. So this is your motherboard. So the motherboard is similarly has a slots like what you have in your desktop computer. So you take it, you slot it inside, and once it's slot inside, you need to configure it. You need to put the configuration on it. It's exactly like you are programming your computer. What is the main component of this one? It's very common to understand it, and it's very important to understand the component. First thing is the power supply module. Normally, the fully comply API 670 system, it has a 2 redundant power supply. You know why I mentionally said non-API 670? Because there is still some items on the manufacturer in the market, they are giving only one power supply. Please follow the logic with me. This is a piece of electronics, like a case of the desktop. In order to make it live, you need to power it. So this is my first card. What is the second card? I need to make this things to speak with the others. So you are building your computer. You need to put what? You need to put your chat box. Okay. More 2 minutes. He gave me 2 minutes. Okay. Thank you. We are just 2 minutes. We'll finish. Okay. Network and communication module. This is exactly where you need this kind of rack to speak with another you need to speak with another system like the SCADA system or the DCS, or you have another PLC, or in future the Industry 4 or digitalization. It has a two common. They have a serial and you have the TCP/IP, and there's no time actually to speak about this kind of details in this this presentation. Right. After I have the power and I have the communication, what else is important for me? The local common phase marker module. So you need to control or to tune the phase or the speed. By the way, speed here on such a model like this or the rack, it's working as a clock. So your clock here, it will trigger another events. And based on these events, you need to start to know when you start and when you end. So this card is responsible for such a function like this. Okay, later on it will come the vibration, common monitoring module. It's not only, I will say, the vibration, it can come in like acceleration, accelerometers, if you would like to monitor the accelerometer, rod drop. It will vary from slot to another. So you as a designer, you will select how many slots you would like to put here and what is the type of it. The standard one is 4 channel per slot. Yes, there is a different, another system, it has more than 4 slots, okay? Or a channel per slot, but the standard of the API is saying the minimum is 4 because the minimum simple of the machine in the industry is the pump, which has a 4 bearing. That's why we put a 4 channel. Later on, you have a temperature monitor module. So, by the way, can I make this one all temperature? Yes, you can. Can I make these cards? It's a 44 channel. Is it possible to make all vibration? Yes, it's up to you and up to the designer. Later on, you will end up with something. It's the dilemma for the vibration or condition monitoring engineer. They don't understand it very well. It's the relay. Relay, to simplify things, is like a switch. You are on off. Like if I say hi, then make the control say hello. So it will answer you. So this is something you need to trigger, and it will take action on behalf of you. So this is what we call it, the relay modules. Some of the condition monitoring system, it's equipped with the vibration. You will find storage, you'll find the communication, and you'll find the relay all in the same card. Still fully comply with the API 670, but they are a bit deviating superior. Let's say deviation in superior. Right. After I finish all of these hardware selection and I build my system, I need to build something, we call it an IO list. In this IO list, I will take every single sensor I have it on my machine. It has a name, and I need to configure it in a software. You have 2 types of the software, and don't mix up. You have analysis software and you have a configuration software. The configuration software from each manufacturer, where you configure the card. When you, like if you have the, return back to the example of the desktop, when you need to install the CD and to put the configuration of the communication card, or let's say the internet card, okay? So this is exactly the same process. So you have a standalone software to configure your hardware. Later on, you have a view or analysis software, so please don't mix up between 2 parts. This is an overview, how this look like, and most common right now, it was very famous that you can see there is something we call it a bar values for the vibration, where every bar it will show you the static vibration quantitative number, how's the severity of it. Now they replace it with the HMI, so you will find like a screen on the front of your panel. This is exactly the full view, except the machine level or the transducer level, where you can put the sensor here. Then after that, you connect it to the rack, and if after onward you will configure it, then you can control it in view in HMI or SCADA system, and you can control it later on if it's dynamic system or VMS system to analyze what's similar product, like Mr. Salah, he discussed the orbit, shaft center line, full spectrum, and so and so. This will fall on this level. Let's see the chat box very quick. Okay, I will try to cover as much as I can, because here I can see Mr. Salah is. Let me take this one on the other screen. We are close to the next webinar. Okay, let's see I will pick like a couple of questions, and later on we can manage it with Mr. Salah. The type of proximity probe used for the radial and thrust monitoring and speed monitoring. As we said, this is, you have a different type. And when you do the design, you need to identify the type of the sensor. Is it for speed? So you need to check the range of the speed, and the sensor under the proximity probe under the speed fall under the speed. Most probably you will find all of them similar to each other, but you need to tell your OEM when you buy the sensor which kind of sensor application you're going to use. So don't mix up. Don't take thermal expansion and utilize it for a shaft gap monitoring, for instance, or the axial movement. So you need to identify the application first, and you select the sensor later on. Another question. How assign X and Y probe location on the gearboxes where it see assigning or let's rephrase your question. You need to know how can we make the provision. Most probably you are not having upper hand on the provision, except if you are running with the Brown machine. A Brown machine is an old machine and would like to install. Most probably we're following what the convention naming and location if you have the full accessibility on XY probe. So you take the 0 from the top, from the vertical, and you go 45-degree positive and 45-degree in the negative. So if you have the room. If not, you need to consult with your OEM. The radial journal bearing temperature tripping should on 2002 or 1002. Actually, I don't understand the question. I don't understand the question. Let's park it and tell to investigate. Let's go for the other one. Trust bearing monitoring. How many? Oh, another message is coming. Maybe Salah is. Do we have a pros and cons of a VL online monitoring system currently? See, the pros and cons I will tell you. You can control it by know the failure. The most catchable or sensible moment when you have a failure. This where you can calculate something, we call it the consequences of the failure. So if you have a steam turbine, for instance, it's just stopped and you don't know what is the reason. When you open it, you find that you have a rub, like what Mr. Salah discussed, and this rub, it's damaged your bearing. And you have a very special bearing and you don't know how long is the lead time or the, let's say, expediting time it will take until to deliver the new bearing. So this one, your machine is look like what? It's look like a dead machine or dead stream. When I mean a dead stream, it means when you buy it, you are not use it at all. You buy a very big asset to produce something as an investment. So you are losing a lot of time. You have to calculate it in dollars. If you calculate it in dollars, you'll get shocked because the whole system, if your system is equal to 1 million, for instance, maybe one day stoppage, it can cost you like a 10 million, 20 million, sometimes 50 million, 60 million dollars per day. Like, okay, so we are so good. So we need to close the session right now. Please, if you have any question, contact with Mr. Salah and we will discuss it later on, inshallah. Thank you for watching, and we will meet in another session soon. Is it possible before we leave to take a snap picture? So can we open a camera for everyone so we can take a snap? I'm not good on this actually, Mr. Salah, but let me take click this one. Yes, I open it. I found it. He's giving me an instruction. Okay, let's make a very good smile for all. And voila. Thank you a lot for making this happening, and thank you, Mr. Salah. Let's meet in another session, inshallah, in the next webinar. Bye-bye to all.